Good morning, everyone. Michael Cohen. I'm the founder of Key AI. I named the company. Everyone calls it QII. It's a Toronto-based 10-year-old company that decided through its services journey with drones to solve the data problem. So about 7 years of development. Right about April 2020, we launched a virtual inspection platform called Key AI. We like to focus on artificial intelligence, computer vision, largely into 2D imagery. We work in 3D, but largely 2D. And our focus is corrosion problems, which really sort of coating breakdown through to staining, through to full-blown corrosion. And then we work on concrete problems as well. We get up these days to work with the Royal Canadian Navy, who's got a fleet that's really end of life. They're trying to restore it, deploy it very, very quickly, turn it around. And corrosion, of course, they sit at water, at sea, so corrosion's a huge issue. And we've been using Skydio to be able to data acquire, the key platform to model, and then quantify, literally measure by square meter, the amount of staining or corrosion on the ship, produce reports, give it to labor for remediation. And I'm thrilled to be here with this panel and all of you.
Hi, I'm Larry Wexel. So I'm the Senior Manager for Artificial Intelligence at our Lockheed Martin Aeronautics business area. We're responsible for a lot of the strategy and various different projects that we have. So let me ask by a show of hands, how many of you flew here today? Maybe not today, this week. All right, so how many of you actually went out and did an inspection of the aircraft before you got on the aircraft? You did? Wow. I knew there'd be one. There had to be one. All right, so if you think about that, you have a lot of trust in the system that's already there. And the maintainers that are out there, they're working to try to make sure that these aircraft are inspected, that every bolt is tightened, every system is checked out. And they're putting their life at risk in a lot of ways, and we'll talk about that in a little bit. One of the challenges with that is they're at high levels. I mean, there's certain aircraft of maybe 5-6 stories in the air, and they're on a cherry picker, so it's a pretty big deal for them to do inspections. And that's not only for the military side, which we're involved in, but also the commercial side of that. So we'll talk a little bit about that today, and that's kind of what our focus is doing autonomous aircraft inspections, and even beyond that, we'll hit on some of those subjects.
Awesome. And then John Montague is here from our solutions engineering team. For those of you who have other problem sets for maintenance and inspection and want a demo and can really see what the drone can do, John's team is out in the field looking at customer problems and how Skydio drones can solve those on a day-to-day basis. So John, maybe a quick intro from you as well.
Yeah, so like Chris gave me the intro there, but I've been in the drone solutions business for about 15 years, worked at a competitor to Lockheed for a while as an engineer, but we're starting to see this technology come together, and these workflows that we're going to talk to today is really tying it together for inspections and ultimately for fleet readiness. So like Chris said, my team is all over the globe, bringing Skydio assets out there, doing demos, working with customers to try to understand their problem set and how we can enable them. And a lot of times it is workflows with partners and others. And we do, just a quick plug, we do have a multi-ship collaborative autonomy demo happening 2:30 to 4:30 today. It's going to be on repeat. So come and see us. It's on south side, kind of closer to the big tent from earlier. But yeah, if you want to interact with us there, you'll get to see some pretty cool stuff. So yeah.
All right, great. Let's jump into it. So we're going to kind of jump into a few use cases. So we're going to try to shape the problem, current state of affairs, and then what these two gentlemen are doing within their industry teams to make things more automated, more safe, more predictable, more accessible, and improve downstream analytics within these spaces. So over to you guys. Larry?
All right, so today we're gonna go through kind of the process that we use at Lockheed Martin Aeronautics to do our aircraft inspections. So there's a lot of benefit from doing this, and actually if you go to the next chart, there should be one more. Okay, so AIR, it's our autonomous AI-enabled capability. We're using a Skydio drone. We have an ecosystem that is more than just drone-based, but the drone is the predominance right now of what we're using. Skydio just provides a phenomenal solution to us with its 3D scan capability, so we can basically go point to an asset that we want to scan, tell it to go around and do that scan. It takes all the imagery that we need, and it's fed through our artificial intelligence pipeline. We'll walk through that in a minute. But the reason why this is important, if you go to the next slide, please. Aircraft inspections today can be a very challenging environment. I don't know if this is a build. It should have had a ring of, next slide, there you go. Okay. All right, so it can be very time consuming. It's not only from the process of an inspector doing the inspection visually, it's also for the equipment movement. There's potential cherry pickers that you may need, as you can see here, getting to the tail of aircraft that are 6 stories in the air. You also have maintenance stands that are moved around, and there's a lot of infrastructure that comes with doing asset inspections. It could also be costly. Again, you've got that support staff, but it's also the equipment that's necessary to do a lot of those inspections. Inducing damage, one of the big keys there is you're moving maintenance stands around and you're potentially running into an aircraft, which happens more often than you think. And then you also have walking on the surface of a wing or other surfaces where you're potentially kicking antennas or other things on the aircraft surface that would cause additional damage. Hazardous inspectors, and this is a big one. So, you know, I'm aware of many stories of anywhere from people falling off a wing and winding up in a wheelchair, spinal injuries, broken arms from falling off of assets. So it's a very big deal in that area. And if we can use a drone rather than have a person doing that initial inspection and to minimize the amount of time they have to do on those type of assets is very important. Sizable logistics footprint, we've talked about that. So the cherry pickers and scaffolding and anything like that that's necessary. Inconsistent outcomes. So if I gave everyone in this audience here today that maintenance task of going to do an inspection, assuming you all were qualified to do it, you would all still probably come up with a slightly different solution. So this provides consistency that's reliable in how we do the inspections. And then adverse mission rate impact. So the whole reason we have aircraft out there from a military side, obviously we have missions to perform, is to get those aircraft back in the air as fast as possible. For the commercial side, none of us liked sitting at the airport. I felt bad on the way here. The flight next to me, they all were sitting waiting for maintenance to come and do an inspection. It actually wasn't an inspection they had to do, and apparently they got scrubbed. So lots of issues can come from that and can impact not only costs for airlines and other things there.
So Larry, real quick, just because this idea has been around for a while, and I just know what we had to go to get all the safety approvals to utilize a small drone flying around assets that cost tens of millions of dollars, and the damage that could be caused to those expensive assets. So maybe just walk everybody through the process you had to go through, why Skydio was a better solution, and it kind of allowed you to get over some of those safety hurdles and approvals to be able to kind of move forward within this space and do this more automated inspection using drones.
Yeah, absolutely. So the big thing there is, well, there's two primary things that make Skydio better than any other drone out there, in our opinion. So it's the obstacle avoidance capability, phenomenal capability. We've done extensive testing on it and are a believer of the capability. And then also the 3D scan. So we basically are able to fly for a very short period of time, and we're able to take and tell the drone, go do an autonomous scan. It flies around the aircraft. We stick the controls in the hands of users when they come out, and we do demos for them or go out in the field, and they instantly hit the I believe button because of the Skydio tech behind it.
Great, thank you.
All right, so I'll quickly walk you through the inspection process itself. So we do the data collection using, again, the 3D scan capability from Skydio. Right now I'm talking a lot about aircraft, but we can go beyond aircraft. So we've been asked to look at dry dock submarines, missiles, the Orion space capsule, various different things. If it needs to be visually inspected, you can use our core engine, our core AI pipeline to do those inspections. So we do the scan using Skydio. We take the imagery that's captured and do a reconstruction. So if you're familiar with photogrammetry, we're basically taking all the imagery that we capture and creating a 3D model. That is then overlaid onto our model that we have of the actual aircraft, and we use AI to identify any defects. So whether it's corrosion, paint chips, or different characteristics that can impact our low observable surfaces, stealth, if you will, those are all included in how we're doing our assessments there. Then we characterize them, so we'll tell you various different things about the defect that shows up, the type of defect it is, the size of the defect, And then that's all relayed onto a three-dimensional model that's available to maintainers and can be integrated into a maintenance system. So that's kind of a fast walk through the inspection process.
Sorry, pass it. So I think one thing too, and because I've worked with you and my team's worked with you a little bit, that I find pretty interesting on the data collection side. I think, there's different aircraft obviously, and you're looking at a lot of different aircraft with this, but like the 3D scan setup for those not familiar with 3D scan is very basic, and you can be trained in a matter of minutes. I think there's, in the future, as we're talking, a lot of repeatability where you can optimize the flight path, optimize the look angles, things like that, which brings us into some of our mission planning capability with the dock systems you heard about today. But maybe you can talk to a little bit about how 3D scan, the setup, the flight aspect. I mean, I think it's in my non-Skydio drones doing 3D scanning missions is a much more complicated task than I think a lot of people realize, and that's a good enabler, as you mentioned.
Yeah, absolutely. So yeah, the 3D scan capability makes it very easy for us to basically set a few presets in the system, tell it to go scan, and it does what it needs to do. So we have the overlap set, the offset from the aircraft that gives us the degree of accuracy we're looking for, the solution, and ultimately that path makes it just super easy the way you guys have architected it. So yeah, I think that's it. Yeah.
All right, Michael, over to you to talk about ship inspection.
Okay. I feel like everything Larry just said, I could probably say about ships. So maybe I'll speak a little bit more broadly about this. The program run in Canada starts with the federal government. They've got what they identify as 19 key industrial capabilities, and 2 of those capabilities would be RPAS and artificial intelligence. And I'm willing to bet that almost every Western government, in terms of their key industrial capabilities, have probably identified those. In the United States, ship-based corrosion for your armed forces is about a $6 billion problem annually, about 300 ships, which probably puts the U.S. problem of corrosion at the budget of a lot of other nations for their entire military. Force multiplier now, of course, is deployments critical to the Middle East and to other areas around the world. So the mission for us is to be able to participate in a large group, to be able to turn around the ship at port and get it redeployed as quickly as possible. And that's a really time-consuming thing that we're trying to build efficiencies in. So starting with robotics with Skydio makes a lot of sense. And then moving on to AI, of course, makes a lot of sense. We like to say in our shop that AI won't replace you, but someone using AI will replace you. And so we make the pitch that, well, traditional methods would be things like ladders and bows and chairs and notepads and engineers walking around the ship. Could you imagine if someone deployed a drone, grabbed imagery, and from the comfort of their office or even home, were able to do an analysis not in days, but rather in hours, and how that would affect labor downstream? A couple of problems emerge in which the Skydio platform was really the only solution that we could bring. One, we needed to take engineers that were corrosion analysis engineers and make them pilots. So that's a bit of a journey. They need to get a regulatory approval, just like anywhere else. But they need to be comfortable enough to be able to learn an autonomous system and then fly it. It's really amazing to me when you get into the defense sector that these are people that operate some of the most sophisticated equipment around the world. They catapult jets, they fire huge guns, they're, top tier in the pyramid of complexity and expertise in mechanicals. But then you show them a, lightweight drone and they say, absolutely not. We're not flying that around. I mean, they fly F-35s, but put a drone around a ship and they're no thanks. So that's a little bit of a challenge. So the technology has to be incredible to bring on site. And then ships, if you can imagine a ship, they are incredibly complex vehicles. Guy wires, mass, lots of entry points, exit points, dissimilar surfaces. So being able to fly around a ship would be an incredibly complex. I draw an analogy to a building facade, 1 out of 10, ship 9 out of 10 in terms of complexity. So the risk model to take non-aviation people, make them aviation people, and then try and image a ship with such resolution that you can perform computer vision on it requires an incredibly high degree of autonomy. Then you've got the pier and other things. There's always people around. You've got to be over top of people. People are on the pier. And so the entire risk profile of the activity tends to be really quite high.
Yeah, so we're talking physical attributes, but there's a high EMI environment as well. We'll take radars out of the equation because that's a little bit more complicated. So being able to have confidence that your solution's not going to fall out of the air or have connectivity issues in a high EMI environment as well, outside of the complicated physical structures that reside on a ship, I think kind of twofold there, with being able to use the vision navigation in the lead to be able to mitigate any EMI interference and continue to conduct your scan.
Absolutely. You know, I'm 28 years in my aerospace career, 20 in manned. Now this in unmanned. Manned aviation has done a marvelous job of learning from errors. My sense, if you dropped a drone around a Navy vessel, that's probably the end of your program, I think.
Yeah, I think that's probably right. Which, you know, higher barrier to entry, similar to what we talked about with aircraft inspection. There has to be high confidence for safety approvals to be able to operate these small drones around equipment. Well, Navy vessels even more expensive than most aircraft, which is, I think, why we've had success moving into this space where others have not been able to. All right.
I think I'd absolutely agree with that, Chris.
All right.
Yeah.
Do you want to move into the rest of your presentation? Or,
I didn't know I had a presentation, but
okay, here we go. So we're going to talk about.
I really didn't. They gave me a flight itinerary,
Oh.
and I'm here now.
So
Why don't I talk about the process a little bit?
Go
that
ahead,
we
that'd be
do,
great.
Because it's really at the end of the day, you've got to work backwards. So I'm going to go a little bit on to where our value prop is rather than just the technology. I really see that the, you know, sort of A to M is a Skydio product in this, and then the N to Z is a software platform. And really what anyone really wants is a report. So what we do is we consult in a little bit, but the Navy essentially scans their own ships. What they would like to do is do pre-remediation, that's a diagnostic phase, then during labor, which is really quite complicated actually in our space because the amount of material that you purchase for paint, for coating breakdown, for staining and corrosion, if I could invite you into my world, is really quite different. And while you may conceive of a patch of staining being right beside a patch of corrosion, if the labor crosses over, then we've got a problem of budget, we've got a problem of time. So having highly specific areas identified for each problem. Once we scan it, we bring it in from 3D scan into our platform. We use a 3D digital twin through photogrammetry like 3D scan, allowing the user to click on any part of the ship and then access 2D. And then from 2D, we deploy algorithms in that make suggestions. We work a little bit like Grammarly. So making suggestions on your grammar, we suggest here is a segmented portion of corrosion. We think it's 0.5 meter squared, and then we have a human in the loop. Almost everything we do is confirmed by an engineer. And then, of course, those results all get quantified, put into a report, and then the report gets segmented by remediation. So if you want to produce a report on the helicopter deck that has paint only in certain areas, that would be specified by the exact location on the ship. They actually divide ships by 0.5 meter frames. And then the remediation of paint, prep, paint, and finish is attached to the report, and then that's our business. So that's a workflow from a drone flight right to report. I hope that's helpful.
Yeah, one thing we talked about before starting the panel is obviously we're kind of talking about phase one on how to apply this technology to maintenance and inspection. So that's for ongoing maintenance or predictive maintenance and solving problems here now. I think the other thing that the industry is lacking is just archival information to show degradation over time that went into current ship design that can be used to inform future ship design or future aircraft design, whether that's materials, layup methods, paint schemes, corrosion mitigation techniques, things like that. So we see this kind of long-term being a phase one approach where we're really trying to solve the time now, ongoing maintenance problem, automate those inspections and make them easier and more predictive for doing predictive maintenance potentially underway for ships in particular, but then also informing future ship or aircraft design to make them more resilient in the future.
Well, Chris, let me make you, you're absolutely right. Let me make the point this way. This is a patrol vessel that's shown on our platform on the left, the 3D model on the left, and then the users clicked and accessed the 2D imagery on the right. Prior to this model, the way that the engineers would work would be on a CAD that's held in a PDF. So ship's probably, I think its manufacture date's about 1987. So all the archives on this ship from the build, one, the shipbuilder may not even have given over the CAD, but two, what the engineers today in 2024 have at their fingertips is a CAD.
So thinking through all this and where you guys on the leading edge of these detections off of inspections done with 3D scans and other methodology, tying together a little bit what we heard today with the X10 for dock and then the on-premises solutions that we're bringing for our government customers. Can you describe what you see the vision is for the future, whether it's higher efficiency, whether it's more remote operations, or with the lack of labor, there's trained and qualified to fly these drones, maybe it's in a remote asset or a contractor or something like that, and maybe just see how you think next 12, 24, 36 or months look like. I'll give it to you first, Larry.
Yeah, so we're looking at the big picture of how we can reduce the amount of time that the maintainers are actually spending on the aircraft. And in our testing, it's looking like we can have at least, depending on the platform, a 10-fold reduction in that time, which is pretty phenomenal and can really help in the field. From a safety aspect, I mean, there's a lot that can go on there. The autonomy aspect of using docks, I think, is going to be very important. So we're wanting to be able to look and say, okay, go scan this aircraft where we don't have to do all those presets for 3D scan and things, and it goes out and just does it for us. So it's a big picture vision there. Chris, you had mentioned the historical aspect. Looking back and seeing what an aircraft looked like before maybe certain maintenance was done on the aircraft is also very important. Depending on the type of aircraft we're looking at, that could become very important to see where certain restorations have been performed. So there's a lot of that I think is part of the future for what we're doing. Yeah.
Yeah. What about? I guess the other thing we're hitting on maintenance and inspection, but for retrofits, back, Michael, to your point, they might not have a digital twin or a model of this particular asset. So being able to do a scan, then re-render that in CAD and looking at different retrofit, if they're putting on a new weapon system, if they're putting on additional panels or things like that, are things we've seen on the ship side. Larry, I don't know if you're seeing that on the aircraft side as well, but because there's not a lot of this information database archived and accessible to new either civil engineering or new design teams, being able to support the retrofit and upgrade process as well for assets that are $1 billion plus in value and really hard to build and replace the fleet is an area where we've seen value add as well.
I think it extends a little bit further. So I think the vision here for sure is once you do it once, you probably can do it every month. Ships go under an enormous amount of damage, usage, crews on and off, those sorts of things. So the asset is continually, it's fairly dynamic in terms of the usage and even abuse that it takes. But when it comes into dock, any restoration literally becomes a construction site. Scaffolding gets erected on the ship. You've got skyjacks around, material around, those sorts of things. So while you want to probably get into some sort of routine of change detection so that you've got a diagnostic, then a remediation, then some sort of commissioning so you understand that the work's been properly performed. And you can understand that trend over time. If you have a baseline, then you've got analytics to show you where you're going. But I see even a workplace health and safety factor where, particularly today with the drone in the box, where now not only is your information getting over to engineering, but it could get over to health and safety, site planning, those sorts of things on the pier because you're now doing repeatable scans. So the force multiplier rolls out to other divisions, I think.
Perfect. Yeah, John, I don't know if you want to add anything in terms of what you've heard in the field during demos in terms of other problems or areas where customers are focused on this. Obviously, ease and usability of the system is paramount, especially if we're putting this in the hands of sailors who maybe have, 3 other jobs and this is not their primary duty. Making it, the ease of use, I think, is a big factor for being able to really deploy this at scale.
Yeah, I think sometimes the hardest challenge is getting the systems on vessels, but some of the other use cases, because this system is a tool that can be used in a lot of different ways, is quick battle damage assessment, or if there's a lot of activity right now and in various parts of the world, if there's damage to a ship or something, getting eyes on that as fast as possible, having it as a part of the safety kit. Someone goes man overboard, using this as an ISR platform in that case, but the same system can do these different applications. So I think we're seeing a lot of utility with our naval customers and others, Coast Guard, things like that, for those types of inspections. Even oil inspections. We've done some testing recently using our thermal camera to be able to see different gradations and variations of oil spills. So there's a lot of extra utility with these systems when you have them in the hands of folks that can utilize them. And since I have the mic, and I would be a poor solution engineer if I didn't ask this, for both of you, what's at least one thing you'd like to see Skydio do better, an opportunity you see of us to improve our product, or a feature you'd like? And we have some engineers and product in here, so they'll have to listen. So here you go.
So I guess before I answer that question, you mentioned battle damage, and one of the big things with battle damage is sometimes you have chem bio that may be used. So sending an asset out there, you don't want to send a human out there if that's the case, immediately at least. And so having a drone be able to do a quick inspection for battle damage is very important. And also airfield battle damage. So that's another application. Facilities inspections. These are all areas that we're looking at ourselves at Lockheed Martin. But that's some of the real deal stuff that I think where drones can play another really important use case. Now, what can we see in the area of what Skydio can improve? We would love to see, well, first of all, the X10 I think is bringing a great capability with accuracy. It's going to help us have a further standoff away from the aircraft, which means our inspection speeds will increase. So you're answering the mail on that. The ability to change sensors on the X10, I think, is going to be really important for us. There are certain sensors we're looking at putting on there, and we'd like to work with you guys on getting certain sensor sets put on there. So that I think is a critical aspect right now that we're looking at. Yeah.
At the risk of repeating, I don't operate. So, but what for our shop, Jonathan, the ability to get the asset scanned as fast as possible with the highest degree of resolution is what we want at all times. The X10 in fact, the X10 has created a really interesting problem for me because of the resolution. We ran on a cybersecurity strategy by which at any passerby in the naval shipyard could park their car, look through the gate, and see the ship. So that's the level of detail that we had with the X2. Okay, no notions of privacy. Public can see the ship. With the X10 now, we're reading serial numbers off of life rafts from 100 feet. So our entire cybersecurity profile has changed. But as a computer vision company, the highest resolution possible. If we could double it, great things happen.
Great. You guys want to open it up to questions in the group to see if anybody has any questions, kind of more detail on anything? Sir?
I'll be your mic runner for the day, everybody. Let you go first, yeah.
All right, regarding the military applications, crap, my question just escaped from me.
You know what? That's all my fault. I started yakking at you guys. Who wants to go next? We'll come back to you.
I'll follow on to that. Regarding military applications for aircraft or ships, can you talk about some of the anomalies that the algorithms would find? Get into detail, especially interested in low observable technology.
So I can't go into a lot of details on the low observable technology just because of the forum we're in right now. But I will say that the general things we would be looking for from an LO perspective we would be able to detect. If you can visually see it, we can basically train our AI algorithms to do that. Corrosion, paint issues are big things. Cracks are big things we're looking for right now in all of our platforms. But the LO arena, there's definitely more secret sauce there. So, yeah.
So Larry, kind of related to that, are there any specific things that human maintainers typically would miss, or you would see error variability across their inspection that you've been able to kind of back out or mitigate using drones?
Sure. Yeah, so I'll give you one example. We were at a base and we're scanning a KC-135. And we were on the ground for several hours that day, and we did not see a corrosion at the top of the tails, probably about 2 inches. The maintenance community wasn't even aware of it. So we were able to use the technology we had to instantly show them what was going on there. And it's because the tail is so high, you really are not able to visually see it that well, especially if you're not focused on looking for that. So that's just one example of how we've been able to use the tech to find something that could be a pretty critical issue.
And then would that go out as a bulletin to other maintainers to look at that specific spot more closely when
It
they're
could,
doing?
depending on how they're doing their operations, sure. Yeah.
Perfect.
Yep.
I guess this is a question for not only the schedule folk, but also for Michael and Larry. So from a military perspective, and you piqued my interest in what you said, Michael, about privacy issue. So to what extent, or have you been engaged in designing counter UAS programs and technologies, perhaps? And to what extent have you all considered that from a user perspective?
Well, not at all, sir. It's just not our business. I'll pass the mic in a second, but I do want to share for this gentleman that our challenge, we do computer vision and for corrosion. We had a Navy observer, civilian, come on, and he wore his best brown-colored sweater that was knit the day he was a visual observer. That looked it was the ugliest sweater I've ever seen. Looks just like corrosion, like it's a sweater designed to fool computer vision. Ships in the background, pure corrosion, everything else is our challenge, just focusing on the ship and those things that could look like corrosion for us is where we focus our science.
Yeah, so I mean, I can't go into any detail on any counter drone type work that we would be doing. Obviously, we're a large defense contractor, so there would be some stuff we could be working on in that area. But I don't know if you guys want to talk more about how you're avoiding.
Yeah, so Skydio doesn't have a counter system. That's not our business, but we do with our XTND, and we're building resilience into these systems. Because counter is the reality in a lot of places in the world, and these systems need to be able to operate. So we know a lot about counter systems and things, and that's kind of what I can say. Unless you want to say more, but
No,
yeah.
I think that's fine. Yeah.
You want to counter.
Correct.
It's a big space. It's a
It-
huge space.
yeah.
It's a big space.
Could I just a question about the end-to-end inspection process, especially in an environment where you might need multiple platforms. Let's say a ship, you got a drone flying around capturing great data now, but now you got subsea inspection happening perhaps, and there's perhaps nooks and crannies where people are walking around with cameras or visually doing. So how is that world of how is that changing the inspection process? And is it just like late fusion of the insights, or is there some sort of 3D scan process happening from the get-go that can bring everything together, no matter what the source was?
Yep. Maybe if you guys could talk about how you segment the scans to get coverage, and then maybe if you utilize the AR overlays to make sure you have full coverage scan, but kind of how you segment over large scans, especially for vessels in particular.
Well, that's a great question, and for everyone, I absolutely do not know this gentleman. Our business is just about to go under the water because that's a missing element for ship inspections. Corrosion happens, foreign species invasion. Contraband actually is a huge issue with ships coming in on the civilian side of things. That's a multi-beam sonar and stereoscopic on an ROV, so we think that's the evolution. You've got a drone above the waterline, you've got an ROV below the waterline. And then I think we're well down a path of probably 360 camera on the interior. That tech is actually quite easy and deployed today. So like Adam showed this morning of sort of an ecosystem to get a holistic data set, I think we're right on the verge of that.
So do you believe these will be like 3 different inspection reports at the end, or you bring it all together earlier to provide one inspection stage?
So I think it's entirely possible with an RGB sensor on top, thermal perhaps if you wanted that, to mate with millimeter precision a multi-beam or a stereoscopic point cloud below the water line. I think that's entirely possible. And then geosync it with interior would be phenomenal. So, and Skydio's right in that ecosystem.
And from our standpoint, we have an ecosystem of sensors that we would use. The Skydio is one piece of that equation. So Skydio can provide certain level of coverage for an aircraft. There are certain areas of the aircraft you just can't get to. So we are basically our roadmap is to use an entire ecosystem to capture the full digital surface of the aircraft to create a digital surface twin.
Got another question here.
Good morning. I'm curious if you, either companies, have done any studies to look at a side-by-side comparison of a manual inspection versus the automated inspection, and what your level of accuracy between the two of them compares, as well as cost time and savings analysis between an automated versus manual. Which one's more accurate, which one's more cost effective and repeatable?
Yeah, so for the aircraft side of the house, we're running a pilot in Marietta, Georgia, at our C-130 production plant. That's what Adam talked about this morning. And we've done comparisons, and the accuracy is very similar to a human, and sometimes even better than that, depending on the defect we're looking for. So it's absolutely proven itself from that standpoint. The inspection speed is definitely faster. As I mentioned earlier, it just depends on the use case, the platform we're inspecting. And especially with the X10 being able to pull off a little bit further, we're expecting those speeds to increase even more. So, yeah, I mentioned we're seeing about a tenfold increase or decrease in the inspection speed for some of these use cases.
Yeah, I think depending on the customer, though, is it a time savings thing? Is it a readiness, uptime, calibration? So I think time savings is part of the component, but readiness and uptime, if we're cutting inspection hours down from 4 to 8 hours per aircraft to under 1 hour, I think there's a readiness component of it as well.
So the variables for us would be on a ship that we would say something like about a 16 meter beam and 70 meters long, so fair size battleship. Probably in the area of 5 days to walk it, and we test this all the time with us. About 5 hours to do it remotely. I'll park accuracy for a second. You need one good weather window to fly. You actually probably need a good afternoon weather window to fly, noon, high sun. Whereas walking it, you probably need 5 good days. You need to transport the people to the ship, of course, because it's highly unlikely. We found that the engineers are generally in urban centers and not where the ports are. So that whole sort of travel, residence, weather, those sorts of things. And then 5 days to 5 hours to inspect. The accuracy, and I'm really surprised to say this as an evangelist for our company, but the accuracy in the field with people with tape measures is horrible. We can do it much more accurately with computer vision, particularly when you're getting into area measurements. Like tape measures are just not really, very accurate. They say to us, well, we need millimeter, and well, you've been using a tape measure and a ruler for the last 30 years. No one's marking millimeters with a ruler. So yeah, we're actually, the science is pretty strong on area measurements for most use cases.
And one thing I'll say what's different than some other drones, Skydio, obviously, we have our vision system and our obstacle avoidance, so we can get very close to things. So if you need that sub-millimeter even level with the X10 and the sensors, you can get very close to an object and take pictures. Obviously, that increases time on station and whatnot, but that is an advantage in why Skydio can get in these places, is because we can get close to objects, we're not going to hit them.
Good question up here.
Yeah, you kind of alluded to my question around interior captures, and do you guys have a solution? Exterior, you have a great workflow on, but can you elaborate on some of the security risk? What might keep you from doing an interior capture? Is that the reason why you guys don't do interiors to the detail that you do exterior? Is it a security issue, or is it more a feature that's not there inside of your current workflow? And if you could ask Skydio or the industry as a whole to create a workflow or solution or a piece of hardware to attach to, X10, for example, what would that look like if you could create a perfect sensor for interior capture?
Well, that's a really good question. I think to get out in front of one part, I think the Skydio would do interiors. It's a matter of what the volume of the interior is. So if you've got like a helo deck or something like that, or a large hangar, for instance, with Larry, I think that's entirely
Yeah, it would be
entirely
It would be the
possible.
volumetric space plus
Yeah.
lighting, right?
Yeah.
It would be both.
Yeah, if you're getting into hallways, it's probably not the right tool. I'll pass the mic on this, sir. Our mission is to be the best at drone-based corrosion analysis, and so we'll leave the interiors to Sony and others.
But Larry, because security was that one aspect of that question, since you guys have a very sensitive program, maybe talk about the security apparatus and the type of drone that you're using, its offline state, while you've been able to get approval to use it for the sensitive programs and assets that you've been inspecting that might kind of check the box there as well.
Sure. So we're currently still using the X2D, which is the defense version. So it has all the right encryption built into it. It's Blue UAS approved. We know the game is changing a little bit on that right now with some of the customers, but that's really one of the key things that also brings us a Skydio U.S. manufactured drone. All that's really important for the type of missions that we do for national security. So.
Yeah, maybe to expand on that. So they're conducting the scan, they're setting everything up locally, there's no external connectivity, and then post-scan they're pulling everything, decrypting everything, pulling it off the SD card locally, and there's no other transmission or external transmission beyond that. So they're basically controlling their workflow and information from start a scan to end a scan to post-process, without any kind of compromise in between.
And I could talk a little bit about the indoor scan. So we do have a mode in our 3D scan. It's called indoor scan. It's meant to, like in a volume like this, look out, and you can look in as well. So it really comes down to what size of interior. So obviously airplanes and ships might be a little small, but tunnels, bigger interiors, the tent we were in earlier today would be fine for an indoor scan, and all the same applications apply. So.
A quick follow-up. I'm in the construction industry, and so we're seeing more and more clients just adhere to some of the ITAR regulations, some of the other government regulations that you typically is reserved for, clients like yourselves. But we're seeing that more in the private sector where clients are adopting those types of regulations. So that was kind of the point of the question around security. So thank you.
I mean, the clients on their own are enforcing.
Correct. Some of our clients, their data security, we're as building interior, exterior. So they're adopting some of the more stringent regulations that are typically reserved for your ships, your aircraft inspections. But we're seeing that like in the data center world and some of the other areas in construction. So.
Any other questions, folks?
Hi, so former helicopter maintainer. So I know how to calibrate a ruler, but how do I calibrate an AI system in my tool shop?
Yeah, so I mean, the way, I won't go into a lot of detail on this, but to say that the way we do our models, it allows us to align the coordinate system. So when we give you a defect, we're telling you an aircraft coordinates. So fuselage, station, waterline, butt line coordinates. We're also telling you the size of the defect. So all of our models have that built into it. It relays that onto a three-dimensional model where you can actually pull that up. You pull up the 3D model, can mouse around it, and then point to the defect that it's showing, and it'll pull up that two-dimensional picture that it took, and you could see what the dimensions of that particular defect were in aircraft coordinates. Yeah.
We do a couple of things. We have known specs on the ship, so we test against that. Of course, algorithm runs confidence levels, so each segmentation would run a confidence level, but mostly real-world testing. So the moment that we have a known fixed thing, then we can test it against what the actual measurement is. But the thing, and it's a clever question, the answer really exists in the tolerance that the client requires, because there will be an error. So if your tolerance is 1 foot, you're happy with that, great. We did roofing for years. Those guys cut out 5 feet by, they'll draw a line, they'll cut 2 feet over from it. If you're in the centimeter range and you're within less than 10%, generally, my experience in industry is clients been fairly comfortable with that because the historicals have been zero.
Thank you.
Any other questions?
All right, I think we're it between you and lunch. So appreciate everybody attending. If you take away anything, you saw a lot of utility inspection use cases today. We think the surface space is just as big in the government market for asset inspection, building inspection, critical infrastructure inspection, and we want to partner with you to solve those problems. So appreciate your time. Thanks, everybody.